Thursday, everybody. Hopefully by now you've gotten through your first few C++ programs without any major difficulty. And now that we know how to do some basic arithmetic in C++, we know how to create variables and how to assign values to those variables. So it's time to go one step further. Once you've given a value to a variable, you may want to change its value during the course of your program. For example, in a game, you might want to add a bonus to a player's score or give the player an extra life. Using the arithmetic operators that you've already learned, along with a few new ones, you can do this pretty easily. So we're going to go ahead and write version 2 of our game stats program. This version is going to manipulate the variables that store our various game stats and then display the results. Along the way, we'll learn about a few new operators. So let's go ahead and get started. I start out in my text editor, and I've got a new document open. I'm going to go ahead and, before I even start typing, I'm going to go ahead and save this as game stats 2.cpp. Okay. So we have game stats 2.0, which demonstrates arithmetic operations with variables. We'll start out, we'll go ahead and include our IO stream, and we'll declare that we're using namespace standard and open our main int. Okay, we're going to use an unsigned int for our score, and we'll set that equal to 5,000. Okay, we're using an unsigned int for this reason. We don't want our player to have a negative score. We always want it to be a positive score. And this frees up the space that the negative values would have taken. So we can now use those negative values, what would have been negative values, to basically we've got that space freed up that we can have a higher score in our int without having to use a double int. Okay? So once we've set the score, we'll go ahead and display it. Just like we did last time, we see out the string score followed by a space. Then we funnel the actual score variable through cout, and then we funnel an end L. Okay, next we're going to alter the value of that variable. And the way we do that, we type score equals score plus 100. And go ahead and display the value of that. Like so. Okay, so what we've done is we've changed the value of score. Right here, we are now saying that we want score to be equal to whatever score was before plus 100. Now, we're going to do this in another way now, using what's called a combined assignment operator. With a combined assignment operator, we take this equal sign and this plus sign, and we put them together. So we say that score should now be equal to plus equal 100. This has the exact same meaning, score plus equals 100 is the same thing as score equals score plus 100. It's shorthand. So it should have the same effect as if we typed out the full phrase, score equals score plus 100. Okay, the next thing that we have is what's called an increment operator. And what this does is it adds 1 to whatever the current value is. So we're going to say that we have an int called lives, and we're going to set that to 3. Next, we want to increment lives so that the player actually has 4 lives and not 3. Plus plus lives means take the value of lives and add 1 to it. We'll go ahead and see out lives like so. Now let's set lives back to 3 again, just by declaring that lives is now equal to 3. And we'll do lives plus plus, which is close to the same as plus plus lives. They both have the effect of adding 1 to it. If we have the increment operator before the variable name, that's called a prefix increment operator. If we have it after, like we do here, that's called a postfix increment operator. And we'll see why that might be different in a moment. Let's go ahead and see out lives and end the line. Okay, next, we're going to determine a bonus for the player based on the number of lives the player has at the end of the game. So we declare int bonus equals. We're going to assume that at the end of the game the player is given an extra life, and we determine the bonus based on that. And I've misspelled bonus here, so let me fix that. Now let's see that out, see out that information. We're going to display both the value of lives and the value of bonus. Okay, so you see we can funnel multiple, even more than 2 things into that cout. We're sending the phrase lives comma bonus, then we're sending the value of the variable lives, then we put a comma between the after the value of lives just to set off the next value, which is bonus, then we end our line. Okay, so this time we're using the prefix increment operator. Now we want to do the same thing, but we want to use our postfix. So we've set lives back equal to 3. And now we're going to say that bonus is equal to lives plus plus times 10. And see out that information. Okay, last thing that we want to do is look at what happens when our integer wraps around itself. We'll set score equal to 429496725. If I remember right, that's 4 billion. Yeah, 4,294,967,295, which should be the maximum value for an int, for an unsigned int, um, in your compiler. So we'll see out the score so we can see the value before we increment it. And then we'll go ahead and increment score by 1. Score, score, and L. That should be enough for this program. So let's go ahead and return 0 to close out our program normally and close our main function. Go ahead and save that. And let me change directories here. Okay, now that I'm in the right directory, I'll go ahead and compile gamestats2.cpp. And it compiles without any error. Now you may get a warning, something like, warning, this decimal constant is unsigned. That warning won't stop the program from compiling or being run. It's a result of the integer wraparound that you will probably want to avoid in your own programs, but this time we're doing it on purpose so that we can see what happens. Okay, so looking at our code, and I'm going to move my window over next to the code so we can look at these side by each. Okay, our first bit, we had our unsigned int score equals 5,000, cout score, and that displays 5,000. Then we add 100 to score. That gives us score equals 5,100. And that was our score plus equals 100. That gave us 5,100. Actually, no, it didn't. Sorry about that. I forgot a line of code here. Save that. And I recompile and run it again. There we go. Okay, first line of code. We've declared and set score to 5,000, which is right here. Our second bit of code, we add 100 to score and then display it. That's 5,100. Now we're using our combined assignment operator. Display the value. That comes up to 5,200. You can see these combined assignment operators on table 1.2. It's on page 27 in my book. If you're using the Kindle version, just look for table 1.2. The assignment operators are important to know, and you'll want to familiarize yourself with them. Okay, next we're looking at our increment operators. Now, we set lives equal to 3, and then we immediately increment it, which makes it 4. You add 1 to something, add 1 to 3, it equals 4. This is using our prefix increment operator. Next, we use our postfix increment operator, and it gives us the same value. So now you're asking, what's the difference? Can't I just use either one that I want? The short answer is, if all you're doing is incrementing the value, yes, you can use whichever one you want. If you're doing something with that incremented value, though, in the same statement, take a look at our next two lines of output. Lives, bonus, 4 and 40. In our first example here, we use the prefix operator, plus plus lives times 10. C++ follows the order of operations here, but not in a way that we might expect. It increments the value first and then multiplies it by 10. So we set lives equal to 3. We multiplied, or we incremented lives, so lives is now equal to 4. We multiplied it by 10. That gave us a bonus of 4 times 10, which is 40. Okay, this time, we're using the postfix. We have lives plus plus times 10. And here, C++ does the multiplication first. It multiplies lives, which is currently equal to 3, times 10, which is equal to 30. That's the 30 that we see here. After it has done that, then it increments lives. So lives becomes 4. Okay, so basically, if you have a prefix increment operator, it will increment that variable before any other calculations in that same statement. If you use a postfix, it's going to do the calculations first, and then it goes back and increments the variable. So that's important to know the difference of. Is that the postfix increment operator works after the evaluation of a larger expression that involves that particular variable. Okay, last item here, integer wraparound. We set our score to 4,294,967,295. You know what I mean. Then we incremented it. We add 1 to it. We had already set it at the maximum allowed value for an unsigned int. It doesn't give us an error message, though. What it does is it wraps around and goes back to the very first possible value for an unsigned int, which is 0. Okay, so now we're going to learn about constants. A constant is an unchangeable value that you name. These are useful if you have a value that doesn't change, but comes up quite a bit in your program. For example, if we were writing a space shooter in which each alien we shot down was worth 150 points, we could define a constant named alien points that was equal to 150. That way, each time we needed that value, we could just use alien points instead of the literal 150. Now, there's two main benefits to using constants. First of all, they make your programs clearer. As soon as you see alien points, you know what that means. If you're to look at someone else's code and see just the number 150, you might not know what the value is for. Now, the second, and this might be the biggest benefit, is they make change easy. Using constants makes it easy to change your program. Let's say that after we play tested our game, we realized that these aliens were just impossible to shoot down, and they needed to be worth more than just 150 points. With constants, all we need to do is change the initialization of alien points in our program. Without constants, we would have to hunt down every occurrence of 150, check to make sure that each one is for the same purpose, the value of shooting down an alien, and then change that to 250. It's a lot of work, and it really falls under the repeating yourself category, which goes against my philosophy of don't repeat yourself. All right, so in Game Stats 3.0, we're going to use constants to represent some values. We'll calculate a player's score and then calculate how much it would cost to upgrade that player's ship. Now let's get her done. I've got a new text document here, and I will go ahead and save this. As game stats 3.cpp. We have game stats 3.0, if I could type, which demonstrates the use of constants. Okay, once again, we'll include IOStream, and we'll declare that we're using the namespace std and initialize our main function. To declare a constant, you use the keyword const, C-O-N-S-T, and you can declare what type that is. In this case, it's an int, and we'll name it alien underscore points. You notice I'm using all capital letters here. That is a convention, but it's a very common one to, if you're defining a constant, to type the identifier in all caps. That typically tells a programmer that that's a constant value and not a variable. So we declare it as an int, and then we set it to 150. And now we're going to declare a variable called aliens killed, and we'll just set this to 10. Now we declare a variable called score, an integer, an int score, which will be equal to aliens killed times alien underscore points. So the score will be equal to the number of aliens killed times the number of points per alien. Let's go ahead and display that score. With an end L at the end. So that should display the number of points that our player has amassed by killing those 10 aliens. This next constant that I'm setting is actually a set of unsigned int constants. These are called enumerations, or enumerators. An enumeration is a set of these unsigned int constants, and each member of that set is called an enumerator. These are usually related and have a particular order. So what we're doing here is we're setting an enumeration called difficulty, and then we open our curly braces, and our enumerations are going to be novice, easy, normal, hard, and unbeatable. Okay, we close the curly brace and have a semicolon there. Now we're going to create a variable of this enumeration type, and the variable name is myDifficulty. And we've defined it as being of the type difficulty. Once you define an enumeration, that becomes like a type of variable. But in this case, the values that you can set is limited to the members, the enumerations that you've defined. We're going to say that my difficulty is equal to easy. Now, We could also use numbers here. Instead of using the names easy, normal, hard, unbeatable. The way C++ numbers these is it starts at 0. So novice would be equal to 0, easy would be equal to 1, normal 2, hard 3, unbeatable 4. So my difficulty, there are 8 possible values we can set to this. Novice, easy, 10 values, sorry. Novice, easy, normal, hard, unbeatable, or 0, 1, 2, 3, 4. Those are the only values we can set for my difficulty. Okay, next we're going to define another type of enumeration. Enum ship cost. And in our curly braces, we have fighter cost equals 25. Bomber cost cruiser cost equals 50. Okay, so here we have defined our enumeration, and we have our first enumerator is fighter cost, which would be equal to 25. This next one, we just put bomber cost. We don't give it a value. Now, because we don't give it a value, it is automatically assigned the previous value plus 1. So without us assigning a value here, bomber cost will now be equal to 26, and cruiser cost we set as 50. Okay, now we're going to put a line of code. Well, first of all, we're going to go ahead and define our ship. So we define a new variable equal to ship cost. My ship cost equals bomber underscore cost. Okay, because the ship that we have is a bomber. So we have defined a new variable with a type of ship cost, and we've set that equal to bomber cost, which, remember, if we look at our enumerations, bomber cost is 26. Now let's go ahead and calculate what it would cost to upgrade our ship to the next level of ship. So we see out to upgrade my ship to a cruiser will cost and then in parentheses we have cruiser cost minus my ship cost Okay, so this bit of code is doing a calculation. It is taking the value of cruiser cost, which we have set to 50, and then subtracting our current ship cost, my ship cost. And my ship cost we have set to bomber cost, which is 26. So 50 minus 26 is what it would cost to upgrade our ship. We should see that replaced with the number 24, and we'll see that momentarily, because that is the end of this program. So we return 0, close our main function, I save my changes, and now we'll go ahead and compile. G++, game stats 3, compiled without any errors. All right. So looking at our output here, we have a cout of score, which is equal to score. And remember that score we set to aliens killed times alien points. Aliens killed is 10, alien points is 150. So 10 times 150 is 1500. Next, we said we wanted to upgrade. Oh, I said to a cruister instead of a cruiser. Let me just quickly fix that. To upgrade my ship to a cruiser will cost 24 resource points. Okay, our code for that, we said to upgrade my ship to a cruiser will cost cruiser cost minus my ship cost. So 50 minus 26 equals 24. Okay, so that's using constants, enumerators, and you can see it's fairly easy. It's fairly intuitive. So next what we're going to do is we're going to write a program that tells a story. And in this story, we're going to use constants, variables, strings, and of course our standard library features. So let's go ahead and get started with that. I will close this and then create a new document. And I will name this document lostfortune.cpp. Okay. We're going to go ahead and include IOStream. We're going to include one other file here. We're going to include a file called string, which gives us some text capabilities that IOStream does not include. We're going to say that we're using stdcout, we're using stdcin, using std and l, and using std string. Okay, we've included the file string, which is a part of the standard library, so that we can use a string object to access a string through a variable. Now there's a lot more to these objects, but we're going to just kind of hold off on that until chapter 3 when we do a word jumble. All right, because I'm using those using directives, you can see that string is in the same namespace as cout, cin, and endl. It is in the std namespace. So let's go ahead and initialize our main function. And in this part, we're going to get some information from the player. First, we define a const integer called gold pieces, and we set that equal to 900. Then we define an integer called adventurers. Actually, we're defining 3 integers here. Adventurers, if I could type, killed, and survivors. Okay, because we are defining 3 here, we can do that just by separating them with commas. Now we want a string called leader. Okay, remember a string is more than one character of text. It's a line of text. All right, next up, we're going to go ahead and get the information from the player, because this will be personalized. They get to decide a lot of the variables. Get the information. Okay, a little bit of introduction here. We have a cout, welcome to Lost Fortune, a couple of line breaks, and some instructions. Please enter the following for your personalized adventure. Cout, enter a number, and cin, whatever number they enter, to the variable adventurers. Adventurers. Okay, cout, enter a number smaller than the first, and cin that value to the variable killed. Now we can do a quick calculation in survivors and set that equal to adventurers minus killed, and cout, enter your last name, cin that input into the string variable leader. Okay, once they've entered this, we can go ahead and tell the story. And we do that using cout statements. We have a line break here, and we launch into our story. A brave group of the value of adventurers gets placed in between these strings. In search of the lost treasure of the ancient dwarves. Remember, when you're typing in these strings of text, if you don't give a space, there won't be any space. Any space that you want, you have to type in. The group was led by that legendary rogue, period, new line. Okay, next part of our story. Along the way, a band of marauding ogres ambushed the party. all fought bravely under the command of their leader, and the ogres were defeated, but at a cost. Of the adventurers, the value of the variable killed were vanquished leaving just the value of the variable survivors in the group. New line. Okay, next part of our story. See out. The party was about to give up all hope. But while laying the deceased to rest, they stumbled upon the buried fortune. And BB Edit is telling me that I've misspelled stumbled, so I'll fix that. So they stumbled upon the buried fortune. So the adventurers split. Now here I'm calling on my gold pieces constant from before, which was 900. Gold pieces, oh, they split gold pieces. And leader held on to the extra gold pieces modulus operator survivors. That needs to be wrapped in parentheses. Okay, we're using the modulus operator to calculate the number of gold pieces that the leader keeps. Remember, this checks what the remainder is of gold pieces divided by survivors. That's the number that would be left over after evenly dividing the stash among all of the adventurers. So if that value comes out to be 0, then this would, of course, say held under the extra 0 gold pieces. Okay, next line. Pieces to keep things fair, of course. Okay. That's the end of the program, so we return 0. Close our main function. Save it. And now let's compile it. G++ lostfortune.cpp. That compiled very quickly. No errors. Let's go ahead and run it. Okay, enter a number. I'm going to say 9. Nah. Yeah, 9. No. 12, like the book says. Enter another number smaller than the first. We'll say 3. My last name. Okay, a brave group of 12 set out on a quest in search of the lost treasure of the ancient dwarves. The group was led by that legendary rogue, Butts. Along the way, a band of marauding ogres ambushed the party. All fought bravely under the command of Butts, and the ogres were defeated, but at a cost. Of the adventurers, 3 were vanquished, leaving just 9 in the group. And here you can see, down at the end, 0 pieces to keep things fair. I can also see that I've left off or neglected to put a space after split. Okay, this time let's run it again, and let's say 13 and another number of 2. Okay, so now you can see split 900 gold pieces, which was our constant, and the modulus of 900 divided by 11 is 9. Okay, hopefully that makes sense. Hopefully you're able to compile that without any problems. And that does it for this week. I have posted your first homework assignment, which is basically a couple of exercises for this first chapter. Next week we'll dive into chapter 2 and start getting a little bit deeper in our code. So I hope everyone has a good weekend. And if you have any problems or questions, please don't hesitate to email me or come in during office hours. Thanks a lot, folks. Have a good one.